Okay, good morning or good afternoon. Today we're going to be looking at all the little graph properties. I'm going to be starting at the very beginning, just so if you forgot anything, hopefully it'll help you remember on what you need to do. If at any point you feel like you need to pause this video so that you can write things down, feel free to. I'm going to be moving through the material fairly fast. Now when we're talking about the first item, domain and range. Domain is the set of possible x values that we're going to be using by the set of equations, or possibly the graph. And the range is going to be the same thing, but this time we're going to be looking at possible y values. Now all of our points are going to be included at this point in time, and so we're going to be writing with a notation where we're going to put a bracket, and then we write the lowest number, and then we write the highest number for that specific variable. The next thing we're going to be looking at is increasing. Increasing, it's pretty straightforward. We're going to be looking for any part of the graph that has a positive rate of change. Now when we write it, we would base it only on the x coordinates. Only the x coordinate part. And so like we discussed, increasing, it's going to be going up and to the right. Decreasing, it's going to be just the opposite. Decreasing is going to be any section of the graph that has a negative rate of change. It's only identified based on the x coordinates. So again, decreasing, negative rate of change, it's going to be going down and to the right. Minimums. Okay, a minimum is going to be one of a couple things. It could be, if I know my graph is increasing, it could occur directly before that one point, and that would be considered a minimum. So before my graph even gets started, that could be a minimum. The alternative could be after a graph finishes decreasing, then it would still end at a minimum. Or when it switches from decreasing to increasing, we're going to have a minimum. A maximum, it's going to be the same kind of concept, where our maximum, we could have it, a graph is increasing and then it reaches a peak, it reaches a high point. And then, or it could be when the graph is going down after a high point, or it could be the point in the middle, like a mountaintop. And whenever we would write these, minimums and maximums are going to be identified based on the ordered pair of wherever that coordinate may be located. Okay, zeros. Zeros are the locations of the x-intercepts on the graph. So all we have to do, it's just a synonym for an x-intercept. The second thing, this is something that I really wanted to look at, is function notation. So if we have f of x equals y, that's just telling us we're looking at an ordered pair xy that matches that graph or matches that equation. The reason why a 0 could also mean an x-intercept is because the equation is equal to 0, and that's why we call it a 0. Okay, in behavior. This is something that you probably haven't seen any of before. Right now we're just going to kind of stick with it in words, and we'll kind of go with it from there. So say this is a picture of my graph, the big yellow line. Now, when I'm looking at it, in behavior is just saying, what are the left and right sides of my graph doing? So the first thing I would look at is, let's say I'm looking at the right side. On the right side, the notation would be x, and then we'd have a little arrow, and then we'd have a positive infinity symbol. And that's just going to mean the right side, because the x values are getting larger on the right side. Then what we would look at is, on the right side, we see the arrow is pointing up. And so for right now, we can just kind of say it in words. We'll move to symbols a little bit later. But the right side, we can see, because of the arrow, will go up forever. And we can kind of just summarize it in words, like I was saying. But if you want to see what the notation would be, we would also say the y values arrow, and then the y values would be going to infinity. Now we're only half done because I only talked about the right arrow. So the left arrow, we would do the same thing. Left arrow, we can see the left side is pointing down. Now the symbol for left, to signify we're on the left side, would be x with another arrow. And this sign, since x is on negative numbers on the left side of the graph, we'd say negative infinity. And we can just go ahead and say the left side goes down forever. And if you feel comfortable using the notation, feel free to, but you may want to say it in words just to make sure that in case you make a mistake. And the actual symbols on that for saying the y values go down forever would be y with an arrow and negative infinity. This statement and the box statement mean the exact same thing. Okay, so I want you to find this graph in your packet. What we're going to do is we're going to start with the domain, and then the range, and then we're going to go into a whole bunch of properties. The goal is to fully analyze this graph. So the first thing I'm going to look at on this graph is domain. So when I look at domain, we said domain is all the possible x values. So I'm going to be looking at my x-axis. I can see that this graph starts over here at -5, and on the x-axis it's going to go all the way over here. Now be careful, it doesn't stop here at 9, it goes one space more. So I'm going to say it stops over here at 10. And so we're going to say our domain starts at -5 and goes to +10. So -5 on the x-axis, +10 on the x-axis, and all the numbers in between. Okay, now range is very similar to domain. Just this time we're looking at our y-axis. So I'm going to look for how low does our graph go. When I look at this, I can see that the lowest point is over here at -9. And the highest point, and then we're going to see that the graph is going up and going up until I reach the highest point, which is here at 4. Okay, the whole graph is in between those two yellow lines. So our range would be from -9 to +4. So all we're looking for is the x-axis, how much of that is taken up, and how much of the y-axis is taken up for domain and range. Okay, so now we're going to be looking at increasing, decreasing, minimums, maximums, and just about everything that we've talked about so far. I'm going to start with increasing in red. So increasing, like we said, was positive slope, positive rate of change. And I see a couple sections of our graph where I have a positive slope, where it's going up and to the right. And I'm going to go ahead and highlight these. And if you need to, you can highlight it on your own paper. So I see 3 intervals. Now when I look at the one on the left, I see it starts at -5, 0, and it ends at -3, 4. Now when we write an answer for increasing or decreasing, we only label the x coordinates. So my first interval would be -5 to -3. Second interval, I can see it starts at 0, -6, and it ends at 4, -4. So again, x coordinates only. So I would say that this goes from 0 to 4. The last section of the graph, we have 7. 7, -9 is where it starts. And it finishes up here at 10, 3. So our last interval would be from 7 to 10. Okay, now let's go ahead and switch over to decreasing. So decreasing is going to be almost, it's done the exact same way. Just this time we're looking for negative slope. So I see I have two sections of the graph where it's negative, and all we're going to look at is the x-coordinates where it starts. I can see the green line starts at -3 and ends at 0. So my first decreasing interval will be -3 to 0. My second decreasing interval, I see it starts at 4. At 4, -4 ends at 7, -9. So my second interval, we would say, is only 4 to 7. And the reason why we're only sticking with these x-coordinates is based pretty much on what we said in the first week. These functions, x cannot repeat. There's only one time where x is +4. There's only one time where x is 7. But there could be multiple y values that could be repeating, which is why we can't kind of mess with those. The next item we have is maximums. A maximum is going to be kind of signified by a change of direction, or it could be kind of at a line or at the end of the line. So we're going to look before a green section or after a red section. So the first maximum that I see is going to be over here at -3, 4. And then I go downhill to 0, -6, but then I go up to 4, -4. So 4, -4 is going to be a maximum because I see that I'm starting to go back downhill again. And then I see I have one more maximum because I finished by going up the hill to 10.3, and that would also be constituted as a maximum. Now, since these are specific locations, we do want to make sure we list the ordered pairs. Okay. Now I'm going to do minimums in purple. Now minimum is going to be done almost the exact same as a maximum. We're just going to start, we're going to look for where it's switching from decreasing to increasing. So 0, -6 would be considered a minimum, same as 7, -9. But it could also be just right before an increasing section of the graph. So -5, 0 would also be a minimum. And we would just kind of write the points. Okay, so we're getting very close to being done analyzing this graph for all just the same pieces of information. The next item is what we have called a 0. We said a 0 was an x-intercept. When I'm looking at the graph, I see that we have 3 x-intercepts. So when we're talking about an x-intercept, we're talking about where does the graph that we've been looking at cross the x-axis. So the 3 points that I see are going to be highlighted in black. I see -5, 0. I also see -2, 0. And I see 9, 0. So our zeros are -5, 0. -2, 0. And 9, 0. Now before I go on to the next slide, there's one more thing I just kind of want to point out, is that we also have a y-intercept on this graph. Y-intercept, we are going to be looking at the y-axis this time. We're going to be looking for our line, where our line crosses the y-intercept or y-axis. We're going to see that's going to occur at 0, -6. Okay, so that's a whole lot of information. Let's go ahead and take a look at the rate of change and a couple other function properties on this. So here's a good question. Why can we not list the end behavior on the graph? Well, the big reason why we can't list end behavior is we said the way we find the end behavior is by looking at the arrows on the end of the graph. In this case, it doesn't continue on. The graph ends. There is no end behavior because there are no arrows. Okay, the last little bit on this graph is we're going to find the average rate of change on the following intervals. Now, again, when we talk about intervals, we're going to be talking about the x coordinates. So this is going to say start at x equals 4, end at x equals 7. So from x equals 4, I'm going to draw a big solid line there at x equals 4 and at x equals 7. And rate of change, like we've discussed, just means slope. The easiest way to find slope on a graph is to count your rise over run. And so from this point here on the left to this point here on the right, we can see that we're going down 1, 2, 3, 4, 5. We're going over 1, 2, 3. So our rate of change would be negative 5 over 3. Let's just go ahead and call it by what variable we're supposed to use. We're supposed to use the letter m. Now 0 to 4, we do the same basic principle. We're going to start at x equals 0 until x equals 4. We're only looking at the 2 points at the end of that interval. How do we get from one to the other? Well, we have to go up 1, 2, over 1, 2, 3, 4. So 2 over 4, but we probably shouldn't list it as 2 over 4. Let's reduce the fraction to 1/2. Now the last one we have, or the next one we have is from 7, from x is 7 until x is 9. So when we look at how do we get from one point to the next, well, we need to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. So our slope is up 9 over 2, and that fraction doesn't reduce, so we leave it alone. Now this last one we have a really large interval. We said it starts at the x-axis at 0, it finishes on the x-axis at 9. So I'm starting at this point right here, and I'm going to this point right here. I do not pay attention to anything that happens in the middle. This might as well not even be here for all I care right now. So we're going to see, how do I go from the dot on the left to the dot on the right? I'm going to go up 1, 2, 3, 4, 5, 6, go over 1, 2, 3, 4, 5, 6, 7, 8, 9. So our slope, or rate of change, would be 6 over 9, which reduces to 2 over 3. And that's how we find the average rate of change. So there's only a little bit I really want to look at from this point on. Okay, complete the statements. We have f of 7 is equal to what? So this is kind of going along with the function notation we mentioned back at the beginning. If we have some coordinate, f of x is equal to y. And that's telling us we need to go on a scavenger hunt on the actual graph. And when I'm talking about the graph, I'm talking about this line that I'm highlighting right here. I'm not talking about the whole grid. I'm just talking about where the equation is at, or where the graph that we're given is at. Saying, look on the graph, find either the coordinate x or y, and fill in the blanks. So when I'm looking at f of 7, okay, so I can see, well, inside the parentheses, that's an x value. So when I'm looking at it, I have an x coordinate of 7. I need to find the y coordinate that goes along with it on the graph. So I'm going to go over here to x is 7, and the coordinate down here would be 7, negative 9. So our answer here would be 7, negative 9. So our next point says, what is f of negative 5? Again, we have an x value of negative 5. I need the y coordinate. So when I look at this, I can see, well, over here at negative 5, the y coordinate would be 0. So that's going to tell me my answer is 0. The next one we have is f of negative 2. That's going to tell us that our x coordinate is negative 2. Find the y coordinate. When I look at this one, we've got negative 2 is going to be right here on the x-axis, and that's going to tell us again we've got a y value of 0, which means our answer is 0. Now when we look at the next two, x is blank, but I have a y. So I need to complete the statement x, and then I need to find an x that has a y coordinate of negative 6. Now when I look at this, I can say, well, 0, negative 6 works. But I can also say, don't we have negative 6 over here at 5, negative 6? So since we've got two of them, we need to list both of them. But we also have a third one. Some people have noticed that we've got over here kind of halfway between 7 and 8. Now, since we're just kind of estimating, 7.5 negative 6 would be fine. But we would want to list all three of these as answers. So 0, 7.5, and positive 5. Okay, the absolute last one on this, we have f of x is equal to negative 2. Find the x coordinate. So this one, since we're trying to find an x coordinate that has a y coordinate of negative 2. So we're just going to look at our graph and see which ones match the best. So I can see, well, negative 2, I can see this point is 2 down, so maybe about negative 1.5. And then I see one more point over here at negative 2, and I'm going to kind of estimate that as positive 8.5. And so negative 1.5 and 8.5 are the answers on that. Okay, so let's kind of talk about the other graph. I'm not going to spend a lot of time on it because I know this video has gone way longer than I anticipated. Okay, I want to start by looking at domain and range of the second graph. So when I'm looking at domain and range, again, domain means my x-axis. So on my x-axis, well, I can see the entire x-axis has a part of a graph either above it or below it. But the second thing is I can see, well, there's an arrow on the right and an arrow on the left, which are going to show that it's going to keep going to the left and to the right. Since it's going to keep going, I'm going to go ahead and put arrows on the side for my domain. What this is going to tell me is my x-axis is going to go from negative infinity to say that it's going forever to the left, like we talked about with end behavior, and positive infinity. Now range, we said range was the y-axis. So I can see that the absolute lowest it gets is negative 5 here. And then I can see, well, the graph is all going up. And it appears like it almost stops at 8. But it's got an arrow. The arrow is going to show it's going to keep going. So when I write my range, I would say, well, this goes from negative 5, and then it's going to go up forever. So I'm going to go ahead and put an infinity symbol. So if you see arrows, you're going to use infinities for your domain and range. So this time we can describe the end behavior of the graph. like we said on the very beginning, as x with an arrow to negative infinity. This just says, what is the left side doing on the graph? Well, we can see the left side's going up forever. And if you want to see the symbol, it would be y with an arrow and a positive infinity. However, if you just say the statement in words, that's going to be fine. The second item we have is as x approaches positive infinity. This is going to be talking about the right side. Where x's are positive, we can see, well, the same thing is happening. The graph it's going up forever. And the symbol for that would be the y's are approaching infinity. So that's end behavior. There's only one other thing that I wanted to talk about. And the next section is average rate of change. Now, if you want to go ahead and check your work on the increasing and decreasing, we have increasing in this section and decreasing on these two. So when we say it's increasing, well, the red starts at -5. The red stops at 4. Even though the red section of the graph changes, it started at -5, it ends at 4. This graph will have this graph only has one maximum, and it has two minimums. But what I want to talk about here is talking about the rate of change. Primarily when we have something like this, when it says negative infinity to -5. So at negative infinity, so really we're just going to start here on the far left side of our graph, and we're going to go over to -5, and we're going to count it just the exact same as what we did earlier. So I can see I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, over 1, 2, 3, 4, 5. So our slope would be -10 over 5, which reduces to -2. Okay, and the rest of it, it's going to be the exact same as what we saw in the first part. Again, I'm sorry that this went way too long. If you have any questions, please email me. My email address is smkintne@garlandisd.net. Since this took about 30 minutes, this means you have an hour to work on the other two graphs that I haven't touched. You are expected to attempt these and to turn it in before you leave. We're going to submit it the same way we submitted the independent-dependent activity earlier this week. You must submit it on Google Classroom. There is a Dropbox for function properties. After you have submitted it, please place it in your binder, and I will send you any comments that that I may have in regards to your paper. Thank you, and I will see you all next week.